Welcome to this video session. In this session, I will be covering the introduction to signals and systems. I will be going through the syllabus in brief, and I will tell you why we have to study this subject, the importance of this subject. Okay, see, the subject code is EC304PC, called the signals and systems. So what is the objective? What is the main reason? What are the reasons that you have to study this subject? So first of all, it is the requirement for electrical engineering. So if you see, all computer related subjects and electronics, they're all run on electricity. So therefore they all come under electrical branch of engineering. So signals and systems is also in the stream of electrical engineering. So it is a basic subject. All right, that is the reason why you have to study signals and systems. Okay, next, what is the other reason you have to study this? See, when you want to study further studies, if you want to pursue higher studies in electronics, and you want to go into a specialization field, such as signal processing. So there is one specialization course called signal processing. So there you have to know what are signals. Only then you will be able to know the processing of it. Okay, so therefore, for that reason also you have to study this subject. Okay, next, if you want to appear for any competitive exams, this subject, not just this subject, all your second year first sem and second year second sem subjects will be the basics of your engineering. So those competitive exams will be based on these questions only. I mean, the questions will be all based on these subjects: signals and systems, digital electronics, analog electronics, and network analysis, and electromagnetic waves, field theory, whatever you call. So they are all based on these subjects only. They are all the basics of the engineering. Okay, so that is one of the reason why you have to study this signals and systems. Okay, so now if you see, what is this signal and what is this system? Okay, so today, for example, if you see, everywhere we are talking of signals. Even a layman talk of signals. How? For example, we talk in terms of mobile. We say, I'm not getting the signal. What does he mean? He means to say that he's not able to transmit or receive. That's what in his term of signal means, right? So therefore, whether knowingly or unknowingly, they are using this term called signal. All right, now what is a system? How is it related? Now, if I have a signal, there should be something that has to process that. That is a system, right? Say, for example, I'm having a mobile phone and I'm making a call. So if I'm making a call to another person, he should, first of all, I should have something that accepts my voice and converts it and sends to the other person, and the other person should be able to receive it and convert it back, and then he should be able to understand what I'm saying, right? So you see, there is a system involved. So for every signal, there will be an associated system. Now, in our case, we are talking of a mobile phone. So even when I want to send a video, there should be a compatible system that is accepting the video. Say, for example, if I'm sending a video from a smartphone, he cannot access it from a basic handset, right? Because the system is not compatible. Though there is a signal, that system is not compatible to accept that. You understand? So therefore, that system becomes useless for my signal. Do you understand the consequence? So therefore, every signal will have a compatible system. Then only it makes sense. If I have signal and I don't have a system, it is of no use. I have a system and I don't have signals, it is again no use. You understand? So that is why this subject is called signals and systems. So they are not separate entities, they are interlinked. So that is why the subject is called as what? Signals and systems. So like I said, I have I've taken the example of a mobile phone. We can send data, we can send SMS, we can send videos, we can call, we can chat. Nowadays, you can even do video conferencing and so many things we can do. That Google Hangouts or Zoom, whatever we are doing, so many things we can do, right? There are all signals involved, and there are systems that are processing and interpreting and then doing the work for you. Okay, in simple terms, signals are existing. We will go to the unit and define what is a signal, and we will define what is a system. But as of now, you have to understand that every signal will have an associated system or a compatible system to work with. Okay, so that is why the subject is called as signals and systems. Okay, now after studying the subject, why should you uh, study the subject is what we were discussing. So to understand the behavior of the signal in the time domain as well as in the frequency domain. Domain means area. Okay. So in the time area, okay, in the time region, we want to find out how the signal behaves. In the frequency region, we want to identify and understand how the signal behaves or the system behaves. You understand? So some things might not be evident in the time region of the signal behavior. We might not be able to understand in the time, but we may be able to understand better in the frequency. Some things may be vice versa. So therefore, we require this signal to understand in the time domain and in the frequency domain. Now, both are different. This area is different, that area is different. Simultaneously, you cannot be in both areas. Say, for example, you can be in America, you can be in India, but at the same time, you can't be in America and India, right? So you go America, there is some difference there. You understand there, the standard there, it's a different way. And here, it is different, isn't it? So that's an example I'm just trying to say. So here you might have different ways of living. See here, you buy, for example, you want to understand the mentality of people in India, you buy things, they won't give you a bill. Simplest, of course, things are changing, but most of the time they will not give a bill. They will produce all fake bills. Whereas in US, most of them, in general, we can say that even you buy a small for 1 rupee, they would still produce a bill and give you. So the transactions are quite what you call transparent there. So the understanding of some concepts might be easier there, and understanding of some concepts will be different in India, isn't it? So I'm just giving an example of how to understand the behavior of certain things in time domain and in the frequency domain. Is that clear? So therefore, you have to understand that domain means just the area. You go there, you understand something. You come here, you understand something. That's all. Just traveling between two different regions you can think of. Okay. Now, how do you travel between these two regions? We will see how that is done. Okay. So therefore, to understand the LTI characteristics, the LTI system characteristics, again, for that reason, you have to study this subject. What are LTI? We will define them as we go through. It's called linear time invariant systems. Okay. And we can also perform analysis of the signals as well as systems by using the transform. As I said here, we want to go from the time domain to the frequency domain, and from the frequency domain, we want to come back to the time domain. How do we travel between them? How do we go between them? Is by this technique called as transform technique. So you have to use this transform technique to go from one domain to the other domain, or one region to the other region. Is that clear? So that is also one of the reason why you have to study signals and systems. So all these topics will be there as we will see go through the course. Okay, so upon completing of this, you will be able to define what is a signal, you'll be able to define what is a system, you'll be able to perform various operations on signals, you will be able to understand, let me go through here, you will be able to understand the elementary signals, what are the different elementary signals that are available, you will be able to understand the concept of an impulse function, a unit step function, a signum function, and they're all different functions. And you'll be able to study the uh, analogy between signals and vectors. And you will be able to study what are orthogonal functions, what is orthogonality. You will be able to do the classification of signals and systems. Okay, so those are all the different things that you will be able to do after completing this course on signals and systems. So you'll be able to represent any arbitrary signal in the time domain as well as in the frequency domain by studying the transforms. So what are the transforms available? So we have three transforms. One is called the Fourier, and the others are called the Laplace transform and Z transform. So you'll be studying in one course, why should we study so many transforms? So one beauty of the transforms is that they all have properties that are very similar to each other. So if you study one transform, extending your understanding to study the other transforms becomes very easy and a lot more simpler. So that is the beauty of this transforms. And each transform is unique. All right, though they have similarities, they have different intended applications and they have their own characteristics. So that is why we have three different transforms. So as we take up the transforms, when we take up the transforms, we will discuss more in detail. As I told you in the beginning, we want to go from one domain to the other domain. And if you want to fly from India to US or US to India, how do we go? Do we just think and disappear there? No, we use the flight to go from here to there. That is an operation we follow. So we get in the flight, we go there, or the ship for that matter. Okay, so we use some mode to go there. So that is a transform we are getting. So therefore, it's an operation we have to perform. We can't simply sit and then say, we are in India, isn't it? I mean, we are in US. We are sitting in India and we can't say we are in US, isn't it? So we have to do some operation. So that operation is what we call the transform operation. So we go from one domain to the other domain by using these three transforms. Are there only these transforms, these three transforms existing? No, there are many, many more transforms existing. In today, there are so many more transforms, but these are the basics that you have to understand. If you study this, understanding any other transform will become very simpler and easier. They are all similar. Of course, they have their own characteristics. So as I said, a signal is always associated with a system. So what type of systems are there? There can be linear time invariant systems. So what are time invariant? As the name says, it does not vary with time. So therefore, there can be linear time invariant systems. So the signal, how it is transmitted through the linear time invariant system is what we will be looking into in this unit number 3. So such as the low pass filter, high pass filter, band pass filter, all that you'll be studying. You'll also be studying something called the convolution. It is one of the important operations called convolution. And then the mathematical correlation of signals. So these are some of the topics that you'll be studying in this course. So as I said, uh, the properties of the transform. So here you can see the properties of the Fourier transform. Similarly, you have the properties of the Laplace transform, and you also have the properties of Z transform. So they are very important. So that why you have to study the properties, they help you to solve the problem in a better way. First of all, what are these transforms? They are a mathematical tool in simple terms. Now, what do you mean by a mathematical tool? Now, for example, if I say draw a line, you will draw a straight line. I mean, of course, if I say draw a straight line, you might draw a straight line. How? You may simply take a pen and draw a straight line. Some of you are very particular. They will take a scale and draw a very straight line. Somebody might use any other tool to draw the straight line. So scale is a tool to draw the straight line. You understand? So we are using some tools to solve the problem. All right. So therefore, these are the mathematical tools to solve the problem. So when we know the properties of these transforms, it helps us to solve the problem much more easier. Much more easily we can solve the problem. So that is the reason why we have to study this transforms. All right. Okay. Now let us again look into what are the other topics that are remaining. Yes. So we have the sampling theorem. We have to study the sampling theorem. We have to study. Say for example, now let me just come to one example of what is called as continuous time signal. So any signal is a function. We will simply represent it. So a function will have two variables. What are those two variables? Independent variable and dependent variable. So in this case, x is a function of t. So t is a independent variable and x is a dependent variable. Simply if I want to draw, so this is at t equals 0, I will consider, and simply some amplitude, I'm just drawing something like this. So this is my function x of t. So this is the y-axis and I'm calling this as x of t. X of t. Okay. Okay. Now this is a function and I've just simply drawn showing that it is existing like this. Now if you consider what is this? So if you consider a point, the interval between 0 and 1, if you consider a point between 0 and 1, so how many points are there between 0 and 1? There are infinite points. Why? Because if I tell of a point 001, where is that? It is existing here. Point 00001. That is also is existing between 0 and 1. Point 9999. That is also existing between 0 and 1. 0.8575321. That point also is existing between the. So you see that any number I'm saying, it's a very small number. So it exists. So infinitely we can say, we can say that between 0 and 1, there are infinite number of points. T can take infinite number of points. So this is the axis for T, the continuous time variable. It is independent. So as T varies, the amplitude varies. So this is what amplitude is a function. So x of t means the function of t. That means the amplitude. X of t represents the amplitude at that instant, time instant t. All right. So at t is equal to 0.005 means x of 0.005. You draw a line at 0.005, you'll get that amplitude. So that is the function value at. So therefore, that is how we are representing x of t at 0.999. Exactly, you go to that 0.999 and draw a vertical line. So you will get the amplitude of that signal. So that is the function value of that signal. So at t is equal to 0.999, we have got the function value. You understand? So therefore, these are all the points. So the amplitude is not zero, or the amplitude has some value at that instant of time t. So what we say is that the t variable is continuous. You take any value, it is existing in that. So therefore, this is what we call it as a continuous time signal. So x of t is a notation for a continuous time signal, or in short form, I will write it as CTS. It's a continuous time signal. What do you mean by continuous time signal? It exists for all values in that range, or it has infinite number of points in the range whatever you are considering. Okay, so that is what it means. Now let us come to another point called the. Now what we do here is, instead of going for all these intermediate values, which are infinite, I will just stick to only integer values now. So this is at -1, this is at -2, etc. If the signal exists for below that also, I will take it. So I will just simply consider what is the signal amplitude at t is equal to -2, what is the signal amplitude at t is equal to -1, what is the signal amplitude at t is equal to 0, what is the signal amplitude at t is equal to 1, what is the signal amplitude at t is equal to +2, +3, and so on. So instead of writing all these intermediate amplitudes, I will simply write what is the amplitude at t is equal to 0, what is the amplitude at t is equal to -1, what is the amplitude at t is equal to -2, what is the amplitude at t is equal to +1, what is the amplitude at t is equal to +2, and so on. Now you see there is a difference between this and this. Here, the function has continuous, it has some value for from here to here. You understand? But here it exists at 0 or at 1 and nothing in between. You understand? So this is we call, that means here the the independent variable is taking only integer values. So this we represent it as n, and we call this as x of n. So we call this as x of n. So you please note the brackets. So here we use a square bracket and here we use the parenthesis. The parenthesis and t is used for continuous time variable, the square bracket, and n is used for what is called as discrete time signal. Discrete. So this is called as a discrete time signal. Now why is this called discrete time signal? It does not exist for fractional values. It exists for only integer values of n. How did we get the discrete time from the continuous time? We did something called slotting here, isn't it? We put at 0, we put at 1. What is that? That slotting is nothing called as the sampling. So we sampled at t is equal to 0. We sampled and checked what is the amplitude at t is equal to 1. We sampled and checked at what is the amplitude at t is equal to 2, and so on. At t is equal to -1, t is equal to -2, and so on. So we got these amplitudes. So how did we convert, how did we get the discrete time signal from the continuous time signal? We perform the operation called sampling. Okay, so we perform the operation called sampling and we converted from the continuous time to discrete time. Now, how do we convert it back to the continuous time? We can simply draw like this. Now you see when we draw, when we join all the points, it might not be giving the exact one. So how we get back the exact one? That is what is the sampling theorem says. How we should sample such that you get the exact replica of the actual signal looks. So all that is what is considered in sampling theorem. So the signal can exist in the continuous time domain or in the discrete time domain, or in the discrete time form or in the continuous time form. So this is what you have to remember. So signal can be in the continuous time or in the discrete time. In general, signals are existing in the continuous time, and how we convert it to the discrete time is by doing this process called sampling. All right. So what are the effects when we do oversampling, undersampling? All that we will be considering in this unit number 5. So as of now, you have to understand that the signals can exist in two forms, that is in the continuous time form or in the discrete time form. In the continuous time form, it will have infinite number of points. If you consider any interval, it will have infinite number of points. So that means the amplitude will be finite, but the number of points that you will consider will be infinite. Okay. So therefore, we can't represent all that infinite number time values in the computer. We want at a different instant. So when we want to process the signal, we want it discrete. So therefore, the computers will process on discrete time basis. So therefore, that is an advantage of converting the continuous time signal to discrete time signal. Okay. Say for example, you're watching the video and we don't want all the information. We just want a gist of the video. So we'll just keep forwarding important points, we just note down, isn't it? So that is what is continuous to discrete. So you have got the gist. So you know that the starting is half an hour video. We want only the important points. So you just forward, and wherever you have not got, you will rewind, and only that point you will get it. You understand? So we have got that information, and we try to build our own understanding. Suppose if you have missed some information and we are trying to recollect, build our understanding on that, we might have missed out something, isn't it? So the our understanding and what the actual information conveyed in the video might be different, but most of the time we try to get the actual information, isn't it? So that is an example I can give you. What is this continuous and a discrete? I'm not telling that it is become. So we have got the information, but we didn't watch the complete video. We want to save our time and we want to just get some things. Instead of spending half an hour on that, maybe 5-10 minutes we just spent and got the information what that video is saying. All right. So therefore, that is continuous time and discrete time. And we got the information. So the signal can exist in the continuous time or in the discrete time. So these are some of the information that you have to understand when we go for this signals and systems. So in general, I've considered why we have to study signals and systems in this course, and why what is a signal, what is a system, why is the subject is called signals and systems, and how the signal, even the system can exist in both. That is, I mean, in any of these two forms. It can be in the continuous time form or in the discrete time form. So since we are having this continuous time form and discrete time form, so these transforms are also applicable for different. So in simple, I want to tell you that Laplace transforms are used for continuous time analysis, and Z transforms are used for discrete time analysis. So if you have a signal that is discrete, or you have a system that is discrete in time, then we go for Z transforms. If you have a signal that is continuous in time, and or whether I mean or whether you have a signal or a system that is continuous in time, if you want to analyze them, then you go for what is called as Laplace transform. That is a simple thing. Okay. And when you have, and again, you have a Fourier. Fourier is quite different, but that is also a transform to go between the time domain to the frequency domain, and come back from the frequency domain to the time domain. Okay, so these are the transforms, and the subject is not very difficult. If you put some effort, definitely you will be able to pass. The subject is a mathematical subject, so you have to solve more and more problems, and we have to uh, solve more problems. Then only you will become more confident with the subject. As we go through, I will be solving more problems and giving you homework problems. If you solve that, definitely you'll get a very good hold on the subject, and you will get very good marks. You can score high in the semester exam. So these are the textbooks for this subject. But these textbooks will just help you to understand the concepts. But as I said, you require to solve more and more problems. So you can refer any local author books for for the reference on how to solve the problems. So you can refer any local author, and these are the books available in the library. You can refer them for understanding the concepts. So whatever notes I will be making, whatever notes I will be giving, they will all be, I would have referred these books and made notes. But problems we have to solve more. The more problems you solve, the more confident you become. So the signals and system is a mathematical subject, so you have to solve more problems. So first you have to be very regular. If even if you miss one, as I told you, all topics are interrelated. So if you miss, then you will not follow thoroughly. Therefore, you have to be regular, and only then you will be able to follow the topics. Okay, so all the best. So once the semester starts, you be regular and attend all the classes regularly, and definitely you will get very good marks and you can score very well. Wish you all the best. Thanks for your patience. See you in the next video. Bye.